Hello everyone, today I'll be presenting Team 1412's project for ENED. But before I move on with the rest of the presentation, I would like for you to meet the team. Me, Dasha Wynn, Malachi Reed, and Ada Lowe. All three of us are engineering students, but Malachi and I are here for the co-ops, whereas Ada is here for the scholarship. Even though all three of us are engineering students, only I have no past engineering experience. Malachi was a part of GE Next Engineers, and Ada was part of a manufacturing company that she would work at. I found myself divvying up the work between the three of us in order for us to finish our tasks efficiently. But that's enough about our team. Let's move on to the real problem and solution.
Today we want to ground us in the scale of the problem of Bangladesh children and their malnutrition. Bangladesh has 6.5 million children, and far too many are not getting the nutrition that they need. According to Bangladesh demographic and health surveys, 31% of children under 5 are stunted and 9% are severely stunted. Stunting isn't just about height, it's a sign of chronic undernutrition that affects the brain development, immune functions, and long-term earning potential. When we looked at the micronutrients, the picture is mixed. Iron deficiency appears to be relatively low because many communities consume iron-rich groundwater, but other deficiencies are widespread. Zinc deficiencies affect about 44.6% of preschool-aged children and 57.3% of non-pregnant, non-lactating women. Vitamin D deficiency is also common among Bangladesh women and children. Taken together, the numbers show a problem that is a multi-level crisis. It is not just about calories, it's about the quality of their diet and access families have to diverse and affordable foods. This is the gap our project is designed to address. Next, I'll outline the key drivers behind the deficiencies and the interventions we propose to change this problem.
So the problem we're focusing on is malnutrition in Bangladesh. It's mainly caused by poverty, lack of farmland, and high food prices, which make it hard for many families to get enough healthy food. Our goal is to reduce severe malnutrition by helping people grow food more easily and at lower cost. Using local and space-saving methods, this idea also supports the global goal of ending hunger and improving people's health. Local farming can create jobs, teach new skills, and make fresh food easier to find in poor areas. When children get better nutrition, they can do better in school and grow up stronger and healthier. Overall, solving this problem can help families live better lives and make communities in Bangladesh more stable and independent in the future.
To add on to what Ada said, I have two graphs here that show malnourishment in Bangladesh. As you can see, the graph on the left shows hypertension and dyslipidemia, which are both caused by malnourishment. And the graph on the right already shows a decrease in malnourishment, but we want to provide and improve that decrease even more, even if it's just by 1%. Any amount of impact we have on decreasing malnourishment in Bangladesh is okay with us. Now that we've established our problem, let's move on to our ideas. We came up with 3 different genres of ideas. We came up with delivering food, which would be through drone delivery or delivery of food to schools. We came up with the drone idea because we thought since the geography of Bangladesh is so diverse, or so, not diverse, but hilly, that drones would be the most effective. That's why we came up with drones. Delivering to schools is just because of our demographic. we wanted to provide to the children of Bangladesh. Our second genre of ideas was growing food. We came up with vertical farms and fish farms. Again, both taking into account of the geography of Bangladesh. Vertical farms are very compact, which is why we thought of that, taking into account of the geography. And fish farms, well, those are full of fish, and there is quite a bit of water around Bangladesh, so we thought it would be a good fit. Our last idea, as well as our last genre, were nutrition pills, which kind of goes hand in hand with delivering food, but we thought that it was a little more different than just delivering food. So we decided to put in a different genre.
The solution we decided to go with are vertical farms. This is because they are cost and space efficient, as they are basically mini farms stacked on top of each other, allowing more food to be grown in a smaller space. They are also able to stay stable with the correct material, meaning they don't need as much maintenance as a traditional farm will need. They are also able to provide the nutrients that are currently deficient in the Bangladesh children community in things like protein, zinc, and iron. Another benefit of vertical farms are that they are able to provide food at a lower cost. This allows more families to be able to afford healthy alternatives to other foods that they may be eating or just not eating at all. Vertical farms are also easily distributed in all areas because of their lightweight design and compact design as well. Unlike traditional farms, they don't need to be on a large plot of land, and things like fish farms have a long construction time and extremely high cost. And the product is also able to be set up very easily in the local community with very few steps to construct them, and anyone can basically do it with the right tools. The goal of this project is to decrease malnutrition by at least 1%, just to make a small impact on a larger issue.
But you may be wondering, how much does a vertical farm cost? Well, it doesn't cost nearly as much as you think it does. Cost is given to us by personal hours times rate times $40. And our personal hours to build one of these vertical farms is only 1.5 hours. So that's already pretty low. But we also add in material costs. These are materials for just a prototype, which is just a miniature to give the consumers shape of the product. This is only made out of balsa wood and straws, which can both be bought in bulk of a lot. We can get 140 balsa wooden sticks for only $18, and for $10, we can get 250 straws, plus a $10 fishing line to imitate a possible tube for water. But on the other hand, the cost for materials of an actual vertical farm is also pretty low. You see, bamboo, which is the material of choice, would only cost a measly $3 USD of bamboo, and that's per unit. As for the rest of the materials, we have yet to find a for sure price of what each would equal out to. So for now, we just know what materials we're using and how we'll use them. In addition to the materials we know we'll have, we also are considering aquaponics instead of fertilizer for the plants, which is a type of nutritional, funny I say nutritional, but it's a type of nutritional water for the plants. And we also are considering, instead of an actual pump, a gravity pump to lower costs. But we're still unsure of these materials. In conclusion, we want to help solve and decrease malnutrition in Bangladesh, especially the 16.5 malnourished children in Bangladesh that need nutrients such as lipids or vitamin D, with our solution of vertical farms, which are very compact, stable, and will help the malnourishment problem immensely. Thank you for listening. Have a nice day. A very nice day, in fact. A very, 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 very mucho nice day.